I'm going to show two forms of chemical bonding, ionic and covalent, but before I do that I need to define some words. First off, there are the subatomic particles, or the smallest part of an atom. The first one is the proton. The proton has a positive charge, and it weighs 1 AMU, or atomic mass unit. You can represent the proton with a lowercase p and an addition sign above it. The next subatomic particle is the neutron. The neutron has a neutral charge, and it weighs 1 AMU, or atomic mass unit. You can represent the neutron with a lowercase n and a circle above it. Finally, there's the electron. The electron has a negative charge, and it weighs virtually 0 AMU. You can represent the electron with a lowercase e and a negative sign above it. Now I'll move on to the larger part of the atom. The nucleus contains the protons and neutrons. This is a Lewis model, and it shows a connection between two atoms. The electron cloud contains the electrons. It will also show you the probability of an electron being in a certain place in space. Now on to valence electrons. The valence electrons are the outermost electrons. A group or family are the vertical columns. This one is alkali earth metals. Now for the vocabulary terms. Covalent bonding is a bond formed by two atoms sharing electrons. Ionic bonds are chemical bonds formed from oppositely charged ions. Chemical bonds are atoms redispersing their electrons to form a connection. The octet rule is a rule that states the number of electrons that can fit into an energy ring, 288. Reactivity is how easily an element will bond to another. Energy levels are shown on a Bohr model, and it determines the number of electrons. The Lewis model is a model that shows the bond between atoms in a molecule. The atomic mass is the average weight of the chemicals atoms formed from the combined weight of protons and neutrons. The atomic number is the number of protons in the atom. Finally, valence electrons are the outermost electrons in an atom. These participate in bonding. Now that those are out of the way, let's move to the bonds. To represent covalent bonding, I have two elements, carbon and hydrogen. I'll move carbon out of the way and just focus on hydrogen. This is hydrogen. Hydrogen's atomic symbol is just an H. This is hydrogen's dot diagram. As you can see, it has the atomic symbol and one dot for its valence electron. This is hydrogen's Bohr model, which clearly shows you how its orbital is incomplete with it missing one valence electron. Now I'll move on to carbon. This is carbon. Carbon's atomic symbol is just a C. Carbon's dot diagram is more interesting as it has a C, but it also has 4 dots for its 4 valence electrons. Carbon's Bohr model is also more interesting. This time you can see that it's missing 4 valence electrons. Now I'll bring hydrogen back to where we can see it. In order to make this compound stable, I'll need to be able to get 3 more hydrogens. Now they can bond. Now we can start the bonding process. The carbon moves towards the 4 single hydrogen atoms, as it sees an easy way to become stable. However, the atoms don't have brains, so this is fairly random. 2 atoms have bonded, so now we can see what makes this a covalent bond. If you look at the bonding atoms, you can see that the valence electrons are shared and not stolen. Both atoms are now one step closer to becoming perfectly stable. As the bonding continues, the other hydrogens react similarly. When the 4th hydrogen bonded, the whole compound will now become stable and happy. Now I'll move on to the ionic bond. For the ionic bond, I'll use sodium and chlorine. I'll just focus on sodium, so let's move chlorine. This is sodium. Sodium's atomic symbol is actually Na, which has nothing to do with its English pronunciation. This is sodium's dot diagram, which shows how it has 1 valence electron. By looking at sodium's Bohr model, we can see how many electrons it is missing. One detail that is important for later is that sodium is a metal. Now I'll move chlorine back. This is chlorine. Chlorine's atomic symbol is Cl. With chlorine's dot diagram, you can see that it's already almost complete. This is also visible on its Bohr model. The orange circle shows that it's only missing 1 valence electron. The detail that you need to know for chlorine is that it is a non-metal. This will be important later on during the bonding phase. Now, as sodium is back, we can see that we only need 1 of each element to be effective in bonding. So let's start. As the information moves away, the atoms are now being freed, and they're ready to react. Once again, they move randomly, but they're still looking for each other. The atoms are getting close to bonding, and so now we can see why this is an ionic bond. The sodium, being a metal, will lose its valence electron. This means that the chlorine, being a nonmetal, will gain its electron. Now the sodium is a positive ion, and the chlorine is a negative ion. This makes them stick together for they are attracted to each other.